All right, guys. Today I'm going to go over Firestarter 5, Firestarter 6, Firestarter 7. So Firestarter 5 was from our worksheet. Now remember, I obviously, no matter what, you should be saying statements and reasons. That has to happen. Even if this is not going to end up being able to be proven, you still have to show up and make an attempt and give me your given. So on stuff that is not possible, you still have to tell me the statements and reasons, and you still have to make an attempt. So I'm still going to write down hx is congruent to hg. And the reason for that is given. Now, when I look at this, that is all the information I have. All right? I do not have any reason why I can make a new statement about sides. So I have hx is congruent to hg. Just because I think those triangles are congruent, and they probably are, doesn't mean I can prove it. That's a really important concept you guys have to understand. If you cannot, just because it's there doesn't mean you could, just because it looks congruent doesn't mean it is provable. I have no more information. I could say something about angles, but that's not going to help me with side, side, side. So I could use vertical angle theorem to talk about congruent angles. But I have no other way to get anything about congruent sides. What we're going to talk about in the next Firestarter is some of the ways that you can know sides are congruent without being specifically told that they're congruent. Is you would see something about segment bisectors or midpoints, or we call it a shared side. That's when we use reflexive property. That would be like if this orange piece right here was part of both triangles at the same time. It's not. This orange piece is only part of the left triangle. This blue piece is only part of the right triangle. Those cannot use reflexive property. Reflexive property is two pieces part of the same triangle, is one piece part of the two triangles at the same time. So definitely not reflexive property able to use. So what we're going to do is we're just going to say, not possible. Say, number 2, or Firestarter 6, is not a proof. I just wanted to give you guys some information, right? Sometimes you'll see a side statement. Like this is called a side congruency statement. It is a congruency statement because we see this little congruent symbol right here. And it's about sides because we're talking about segments. Segment AB is congruent to segment DE. This over here would be an angle congruency statement because I'm talking about angle ABC is congruent to angle, right, ABC. So that's an angle congruency statement. So you see the congruency symbol and angles, all right? Sometimes you'll be given side statements as information. Sometimes you'll have to use some information to create a statement. Either way, in order to finally prove our triangle, you'll have to actually say side, 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 angle, side. You'll have to have 3 congruency statements. All right, so we don't have that yet, and this isn't going to happen here maybe because we're not really doing that type of work. We're not proving a triangle to be congruent. Now, this is neither, the second one, this statement right here is neither a side statement or an angle statement. It's just information, and it's given to me. So what we're going to find out is that bisector means it cuts 2 points directly. Bisector cuts something in half. So if I have a segment bisector, I have these 2 points, A and F. C is a segment bisector. Bisector means that it cuts 2 pieces in half. So one of the ways that I could say AC is congruent to CF is because the definition, and that's just a fancy way to say definition right there, it's like math shorthand, of segment bisector. So because I know what segment bisector means, I get to say definition of segment bisector is a reason why these 2 sides are congruent. Sometimes they'll talk about midpoint. Midpoint's the same thing. If C is the midpoint between AF, it means those 2 are congruent. Now, if I don't know what midpoint is, I'm not able to say this statement. So this is because I had to know the definition of midpoint. So the idea here, guys, is that we use information from the problem. So this information right here directly led to this statement. This is the side congruency statement. Right? So my given information did not give me a side congruency statement, but I used it to create a side congruency statement. And same as below. This information right here, the midpoint, gave me this side congruency statement. All right. Now the other type of information that you may see is like this next one right here. AB is congruent to AB. That's a big red, like that should be a big red flag. I see something congruent to itself. Sometimes you see like AB is congruent to BA, that's how they write it. But either way, it's the same thing. It's like when you're looking in it, I try to think of it as I'm looking in the mirror. So if I'm looking in the mirror, right, it's like a reflection. So anytime something is congruent to itself, we say that's true because of reflexive property. This will not almost always show up when we're talking about shared sides or shared angles. So reflexive property is one of the only things that can do both angles and sides. That doesn't happen with everything. So that's important. Now the last thing we're going to talk about is that word bisects again. It's important to know what bisects what. So when I look at the word bisects, I see the segment is bisecting the angle. That means the segment is cutting the angle. So this is not a segment bisector, this is an angle bisector. So if I were to draw a picture, which sometimes is hard, but usually sometimes helpful. So it cuts angle DAC. AB cuts it into two equal pieces. So I know this piece is congruent to this piece. So we can say angle DAB is congruent to angle CAB. So basically, that's going to be the definition of angle bisector. So angle bisectors will always give you angle statements. Segment bisectors will always give you segment statements. And this is just a bunch of different ways we could see how given information leads to a congruency statement, whether it's angle or side. It's not about the proof. We'll get there in a little bit. All right? All right. Firestarter 7. We're going to use SAS. So remember, first thing I'm going to always do is statements. I'm going to write it out. Remember, proofs have to be legible. It's like going to court. You're trying to prove something in court almost. It's a formal argument, like a formal dance. You have to make it look nice. All right? So I always start with that. Now, the first thing I see, that's written there. That is given. G is the midpoint of FL. Given information. Why? Because it's written there. You can't argue with something that's written down. Then you also get to say G is the midpoint of HM. Once again, given information. Now remember, this is not a side, nor is it an angle statement. So more than likely, these two given informations have to lead to one of those. So when I think about the word midpoint, so G is the midpoint of F and L. That means I get to say this guy and this guy are the same. So I'm going to say LG is congruent to FG. And the reason is not because I'm not sure, but because I know what the definition of midpoint means. And then actually G is also the midpoint of HM, so that means this guy is congruent to this guy. That means I get to write down MG or GM is congruent to GH. Once again, same thing, definition of midpoint. So guys, once again, I was given two pieces of information. This blue line led to the next blue line. That's an actual side statement. The green line of given led to the green line of a side statement. Now, I need to have a side statement, and I have to have an angle statement because I'm doing SAS. I also know that somehow that when I say SAS, that on the picture, on the diagram, the angles have to be in between the two sides. So what that means is this is a side right here, this is a side right here. The angle in between is where the congruent angle has to be. So I know just based off of SAS that being the rule, because I told you that, I know I somehow have to figure out a way to say angle LGM is congruent to angle HGF. I have to be able to say that. Now, luckily, I remember something from back in earlier in the class. We talked about angles that are across the street from each other. Angles that are across the street from each other are called vertical angles, and vertical angles are always congruent. Right, it's a theorem. Vertical angles are always congruent. So that means I have proven two side statements and an angle statement. And most importantly, on the figure, right, I see a side, then look, it's connected to an angle, which is connected to another side. Unless they're connected, that doesn't count. So imagine that red was not there, but I had proven this angle and this angle, which I did not. If that black angle arc was there, this would not be solvable for side, angle, side. It is not, because the black angle would not be touching both the congruent sides. All right, so we need to understand location with side, angle, side. But luckily it does. And now it's really important when you write your triangle congruency statement that your correspondence is correct. So how I do it is I look at the first, so I'm going to go to L. I'm going to write L first. L's on the left triangle, and I use like directions. He lives at the corner of one dash and no dashes. So when I do triangle, I look at F is at the corner of one dashes and no dashes. So those guys are on the same point in relationship to one another. They correspond with one another. Then I'm going to do M, because M is on the corner of two dashes and no dash. So that means he corresponds with H. So order really does matter. And then they both end with G. And that's going to be SAS. So every proof we do will begin with the given information. Every proof we do will end with the triangle theorem until we talk about Cpctc, which is the next worksheet. So we'll get there. Cpctc basically says when we used to fill in all the arcs and dashes because we knew the triangles were congruent, that's Cpctc saying we know these are all congruent now. Now that I know the two triangles are congruent, I could say other angles and sides are congruent. We're not going to go into that yet. So that's it.